I've heard from a number of people that one of the reasons they purchased the Jetson or a Nano Super was kind of as an educational purpose. So AI is becoming so much more popular lately, and a lot of folks have found that a little 250 all-in-one device is really a great thing to have in terms of actually getting your feet wet and learning more about AI. Now, in keeping with the spirit of that sort of direction, what we're going to be doing today is going through the NanoGPT GitHub repository, which, to put it very simply, is actually going to allow us to train and then run our own little tiny LLM model. Of course, that is somewhat of a oversimplification of comparing it to bigger LLMs and things like that. However, from an architectural and foundational standpoint, at the end of today's video, we will have essentially gone through the steps that power the ChatGPTs and DeepSeeks and Google Geminis of the world. So this is really designed to be a kind of in-depth yet surface level look at some of the more inner workings of AI language models. Now, truth be told, we can quite simply start with this repository and basically just immediately get going. However, because of the Jetson and some of its niche and specialty, we actually do need to go and follow a few prerequisites that will allow us to install specific versions of necessary packages. Now, in order to do this, I have basically just assembled a small instruction manual and pasted it as a gist on GitHub, which you can just kind of think of like an online sticky note sort of thing. So I will go ahead and make sure that I share this. Probably I'll put it in a pinned comment, but this is a fresh install of Jetpack 6.1, so nothing has been pre-configured on here. And I like to do that on purpose because it just helps kind of make sure that any issues that would have perhaps been encountered will be encountered, so then we can work through them together and see why they happened. With that said, we're basically just going to get started. So the first thing I have here is to check the version of Python 3 as well as Python 3 venv, which just allows us to make virtual environments. I have checked these, and on this blank install of Jetpack 6.1, they do exist. So we're basically just going to skip over these, but they are there just in case there is an issue. And truth be told, we'll just kind of go and run this command anyway, which will install virtual environment. And then if it is there, it will basically say that it is already there. Oh, good. I'm glad I did that because we can see that we may not have had that. So that is very good. So the first thing we're going to start by doing is copying this sudo apt install python3.venv. And upon completion of that, we can basically go on and move on to the next step, which will be cloning this GitHub repository onto our local machine. Now, for those of us who are not quite as familiar with GitHub, it is just kind of, think of this as like a file storage section and then instructions. It's far more than that, but for the purpose of what we're doing here, this is basically going to copy all of these files, folder names, and their directory structures to our local machine so we can actually go ahead and follow along with the repository on our local machine. In order to do this, we can simply just type git clone, and then we take the actual URL of the GitHub repository. And you see that happens very quickly because it's not downloading a large amount of files, and it has cloned it into NanoGPT. Now, to see that, we can open our file browser, and we will see that we now have a NanoGPT folder here, which contains all of the GitHub folders and files. However, it's easier to work through this in the command line for what we're doing. So to get into that folder, we just type cd for change directory, and then the name of the folder we're trying to go into, which is NanoGPT, and make sure you type it correctly. And we now see that we are in that directory, and if we type ls for list, it just lists all of the subfolders and files, kind of the exact same thing we see here. Now, unfortunately, there is quite a bit more in terms of prerequisites to actually get going. So the first thing we're going to do is just make a virtual environment to do the rest of this in. This will basically contain all of the package installations and potential changes to the system we make within a virtual environment in order to prevent changing anything in like the base system. So this is just good practice and a good way to make sure that you isolate and contain any potential issues from affecting other parts of the system. So we now have created a virtual environment here named Nano LLM, and that is, so Python 3-m-venv is to create the virtual environment, and then whatever we type after the venv, in my case, Nano LLM, will actually be the name of the virtual environment. Our next step, now that it's been created, is to actually activate it so that we are working from within the virtual environment. To do that, we just type source, name of the virtual environment, /bin/activate. And once we do this, we're going to see that we see a change here, which the name of the virtual environment is now appended to the beginning of our just general shell prompt here. So that means the virtual environment is activated and we are in it. The next thing we are going to do is something that will make a little more sense if I show you this. So in the repository from the quick start, or well, above the quick start, we have to install these dependencies. Now, one of these is Torch, and just think of Torch or Pytorch, I'm using them interchangeably, as a deep learning library and framework that will allow us to work with some of the training and model aspects of this NanoGPT repository. So we need to install that. But if we did the general pip install Torch, something that would likely work on like the Ubuntu desktop behind me, it won't work because the Jetson needs a specific version. So to get that, we actually need to go to this URL, which is developer.nvidia.com/embedded/downloads. And once we're here, we see that we are in the Jetson Download Center. And there is a whole lot of Jetson specific downloads here. But for what we're doing, we only want to look at Pytorch for Jetpack. Now, I am using Jetpack 6.1, so please make sure that if you're trying to follow along with this, your Jetson is also using Jetpack 6.1. If you have newly received it, you will likely have gone through the installation steps and will be running this, but I just want to make note of that. And we basically just click the drop-down arrow next to it here, and we click on this download right here, which will download Pytorch, which it says what it is right here, but it is an optimized version for our Jetson and for Jetpack. So this will allow it to work well and take advantage of the Jetson's uniqueness, if you will. So we just kind of wait for that to download. I think it's like 700 or 800 megabytes. Yeah, 770. So, and I will clean this gist up because it's arranged so like I can understand it easily, but I will amend it to follow along with the instructions in the video so it makes more sense. All right, so assuming that you have a default Jetpack install and haven't really changed much, it should have downloaded that Pytorch installed to the downloads folder. And assuming it has done that, we can then basically just go ahead and run this command. So pip install, and then instead of just writing like pip install Pytorch, which would work on like a system like that, or pip install Torch, I'm sorry, it will go ahead and just install it from the custom NVIDIA package that we just downloaded. And this may take a little bit of time. And once that is completed, there are a few more prerequisite steps we need to do to make sure this will all work for the Jetson that we are using. So I am just going to clear the terminal here. And some of the things I'm going to do right now will benefit from just having an in-terminal text editor that we can access. So for that, I like to use Nano, not to be confused with the NanoGPT repository. Nano is just like a little text editor that works within the terminal. So that does not come pre-installed in the base Jetpack installation. So in order to install that, we are just going to type sudo apt or apt-get and then install Nano. Now I've already done this on this, so it says Nano is already the newest version. However, if you had not done that, it would just probably prompt you for your password and then go ahead and install Nano. And once that is done, we are actually going to do something to test something, the Torch and CUDA installation on the system, which will make more sense once we finish the step. So just bear with me here. So the first thing we're going to do is just type Nano and then just type like test.py to make a test, a Python script named test. We are then going to copy this in, and you don't want to just right click and click paste. I mean, okay, you can, but you could also type Control-Shift-V, which will paste something into the terminal on an Ubuntu system. The next thing, we do Control-O to basically save this, and then Control-X to exit out of Nano. So we are just going to type Python test.py and that will actually go ahead and run that script. And we can see that we get an error here saying this libq sparse lt.so.0 is not found. So we're encountering issues that perhaps would not happen on like a random Ubuntu desktop like what's behind me. Fortunately, there are good ways to solve these. The first thing we're going to do is install CUDA, which you may have heard of in relation to NVIDIA. And I guess just to put it simply, this is going to allow us to like utilize the GPU more efficiently for like machine learning tasks. That's a really very basic way to put it, but for the purpose of this video, it is sufficient, I suppose you could say. And we can see, okay, we're just doing this and it is installing CUDA. Now, in order to solve that issue that we just saw there, just installing CUDA won't actually do it. So if we basically go ahead and try to run this Python test script again, we see we still get the same error, even though we're getting closer to the necessary packages. The final thing we need to do is go to this address, which is developer.nvidia.com/cu-sparse-lt-downloads. And we will paste and go here, and there are a few options we will need to select before we download this. So we select our operating system, which is Linux, even though it's Jetpack 6.1, this is kind of an Ubuntu sort of thing. And for architecture, we are going to click AArch64 Jetson. Following that, we will select native as it's the only option. And then distribution, we are going to select Ubuntu because this is built off Ubuntu 2022.04, which we see down here. And for installer type, we are just going to click deb local, and it will basically go ahead and give us the instructions to do this. So I didn't actually click download here because the first time I tried this, I did it remotely through a different machine. So I do believe we can just basically sequentially follow the commands listed here, and it will go ahead and download and get us set up. So that's essentially what we're doing. And if you try to copy paste these all into the terminal at the same time, it'll probably copy the, it might not, but I'm just doing them one at a time just to kind of try to alleviate any potential like syntax errors, if you will. So we can see to install the key, run this command. So instead of run this right here, so this was the first command. The second command is what we just have run, and then the next command would be here. However, we can just copy what it says in the terminal because after command number 2 that we enter, it actually outputs this, which we then will paste in. And following that, I do believe that we can go ahead and skip this one. As we can see, we now will just do sudo apt-get update. So we don't necessarily skip this command. It's just that whatever it had output in the terminal here to install the key, run this command, we can just kind of do that instead of this one. That was probably convoluted, but I would hope it makes a little sense. So we basically just wait. The update can take a while, but in that case, fortunately, it didn't. And the final thing we're going to do is install that libq sparse thing that was giving us the error in the first place. And we'll do that. And assuming that everything does go well, and however long it takes, we will then be able to go ahead and run that test script, which basically is really a quite simple thing that just tries to import Torch and see if Torch works, as well as if our CUDA device is available, which is just think of as like your video card, which for the Orin is like, just think of it as the GPU, if you will. So we have now done that. And we are just going to once again do python test.py. And it will take a little while. However, upon completion of this, we see first and foremost that we didn't get that error anymore. So what we just did fortunately worked. And we can see that, okay, we have a NumPy issue. Don't worry about that right this second. Torch version, and then it gives the custom version that we had downloaded from the embedded downloads. And we see we have CUDA available, and our CUDA device is Orin. So basically, this is a good thing. And we are now basically prepared to actually utilize the graphical capabilities of the Orin Nano to train a tiny LLM and then play with it. So we are going to press clear here. And truth be told, the next thing that we're going to do, I kind of don't remember if I had to do a follow-up to this, but just follow along with me now. So we're back into the NanoGPT repository, and we are going to need to just install the required dependencies for this. However, remember, we installed Torch from NVIDIA, so we did that separately. So all I've done here is just kind of remove that from this installation command and keep all of the other necessary packages. So we just copy paste that. It will perhaps take a little bit of time. And the thing that I had referenced prior to this, where I said there was something I'm not sure if needed to be done, but I'll check if it is. I had some issues running this where it was giving me a NumPy compatibility error with the version of NumPy that it's downloading here, which is 2.2.2. So if that maintains to be an issue, we will just downgrade it by running this. However, I don't know that we'll need to do that. I just kind of wanted to bring that up to be keep you fully in the loop of like all my thought process during this. And we can see once it is completed, we will just be returned to our default prompt. And I'm just going to clear the terminal so that it doesn't get messy, if you will. The next thing we're going to do is essentially begin playing with the model. Now, the first step in actually performing the instructions here under the quick start are to actually prepare the data for our model. Now, please keep in mind that I am going to be very casually explaining some things that are perhaps technical and more complex than how I describe them. So don't like scientifically analyze every word I'm saying here for the way I explain these. It's just like mostly correct, but it might not be like completely 100% fact. So with that kind of disclaimer out of the way, when we go and see the quick start here, the first step is to essentially prepare the data set so that the model can be trained on it. Now, you and I as humans who read essentially look at kind of text just as like, oh, if you are not a. We look at them just kind of word by word. The LLMs and AI language models like this don't actually understand the data in that way. They understand it using numerical representations of these words, if you will. So they understand math. They don't necessarily understand the English language. In order to basically prepare the data for the LLM to be able to understand it, there are two different ways that are described in the NanoGPT repository. What it says here to run is the Shakespeare_char prepare.py. However, if we go into the data folder here, which keep in mind is also on our local machine, it is the same exact folder and file directory structure as we had just cloned this onto our system. So we can see in data, we have the same exact folders that we see here on GitHub. I'm just showing it on GitHub because it's just a bit more readable, if you will. We have the Shakespeare folder and then the Shakespeare_character folder. So when we do actually go ahead and run this first prompt in the quick start, instead of using it with the Shakespeare character folder, we are just going to be using it with the Shakespeare folder. Now, the reason for this is that the Shakespeare folder has a slightly different way of preparing the data set for training the model, and this way is actually more aligned with what our modern day LLMs actually use. So I am going to show this, and it will seem confusing at first, but there is a cool visual way to actually be able to see and understand this. So here is our data set first and foremost. This is a big Shakespeare data set, and if we copy this, and we can just paste it here because we're done with that page, we will see that it is essentially just a very large amount of text related to Shakespeare lines and sonnets, or whatever you want to call them. I've forgotten that portion of high school, so but regardless, so we can see it is just basically like a big text data set. Now, what this is doing is tokenizing the data. Now, as we see here, it is using the tick token GPT-2 BPE. So it is using the GPT-2 byte pair encoder tokenization or tokenizer. Now, okay, I said that, but like, what the heck does that mean? And I get that. So fortunately, we have access to a kind of really cool online piece of software here. And essentially what this is it shows us how tokenization actually happens for different tokenizer schemas or architectures. Again, that's more of a like unscientific way to put it. So let's go to our data set here and just copy one of these sentences. We're going to now go back into this ticktokenizer.vercel.app, and you can see here, okay, this says GPT-4o. We can actually select this dropdown, and we can go and find GPT-2, which will be similar to what we're using in the NanoGPT repository. If we paste that sentence in, we can see that this is equivalent to 10 tokens. Now, that could be kind of confusing because it's 1, 2, 3, 4, 5, 6, 7, 8 words only. However, this is cool because it actually shows us specifically how this is broken up into tokens, depending on which of these tokenization schemas we select. And we can see that the word before for our model and for training it once it's been tokenized will be reflected by 8421. We is 356. Proceed is 5120, blah, blah, blah. So this is actually kind of what the tokenization does when we run this data preparation script. I understand this could be a little dense and verbose. Just know that like the following sections of this video will just be more like fun and like seeing things happen. So we're like over the arc now of like the dense stuff. So basically this is how this sentence gets broken up for the model to actually be able to use it and train it. So numerically represented. Of course, this is somewhat of a simplification, but it is cool to actually be able to see because visually being able to see some of this stuff really helps with understanding it. If we were to change this tokenizer from GPT-2 to say like Google's Gemma. So right now we can see that with GPT-2 tokenizer, we have 10 tokens here. If we go to Gemma, we will see that once it loads, we have 11 tokens here now. And basically, so like for Gemma, before gets actually cut up into two like partial words. So tokenization doesn't necessarily just have to be word by word. It can be segments of words and things like that. And that still works fine for the models to understand. Now, with that out of the way, and props to this website because it is really cool to see how the tokenization happens in a nice and aesthetically pleasing way, if you will. Unless you're colorblind, maybe then it's a little more difficult. But aside from that, we basically can now go back into the data preparation script and understand that when we run this right now, what's going to happen is all of this textual data is essentially going to be tokenized into data sets, which will look similar to, well, they are fundamentally similar to what we just saw, where all of the words become numerical representations. And once we do this, we are going to see that we end up with two data sets, a train.bin and a val.bin. So it is a 90-10 split. So 90% of that text data that gets tokenized is going to be used to train the model. So think that will be used to teach the model. And then the 10% that goes into the validation data set is going to be used to test the model. So this will make more sense as we actually get going and run it, but I just wanted to kind of give that slight precursor, if you will, because I really think it helps to have a little bit of like foundation when we actually run this. So basically all we're going to do is copy paste this, but remember, we're not using the Shakespeare_character folder. We're just using the Shakespeare folder. So when we do paste this command in, we are basically just going to delete it. So it just says Python space data/Shakespeare/prepare.py. And as we press enter here, our system locally is actually going to go ahead and tokenize that very large data set that we just saw. And we can now see that our training data set has 301,966 tokens, and our validation data set has 36,059. Sorry, I'm getting like excited for some reason. I have no idea why. So basically, our next step is actually going to be to train the model on this data. And that becomes a bit more difficult to actually like go in and understand. So for example, what we're going to be doing now involves the train script. And we can see that if we click on this, it is basically like building a little like training script for a model or something like that. You can see this trips me up too. So it is dense and more difficult to understand. But fortunately, for actually going through and running this repository, we don't really need to understand much of what's going on in here at all, because we'll still be able to actually see the outcomes of what comes from running these. The only thing I will say is that there is a thing that we append prior to that. And as we can see here, so if I go back into the script, we see that there's a config/train Shakespeare character.py. So essentially that's kind of like an override to set some of these parameters to reflect the tiny little model that we are training, which is a small and non like heavy duty model. So if we click on that here, we can see like, okay, this is our baby GPT model. And excuse me, these things are probably more verbose than what I want to try to explain on camera in a more beginner focused video, because I will just probably butcher that. But if you do want to actually kind of get a better visual understanding of how some of this works, there is one thing I'm going to suggest looking at, and I will also put this in the GitHub gist that I will paste to go along with this video. So let's just type GPT-3 on napkin, because truth be told, I don't really remember what it... Okay, so we can see that this is the GPT-3 architecture on a napkin. We're not going to go through this together, but basically this individual kind of simplified a lot of the architectural explanations of the models. So like, okay, what are inputs and outputs? So here we can see an input sequence, and then it goes into GPT and it's trying to guess how certain it is, like the percentage of what the next word will be. And it works like that. So not are all heroes wear, and then it's 90% guessing that it's capes, 5% that it's pants, 2% that it's off. So again, we're not going to really go through this, but this really does give a more simple approachable understanding to some of the actual architectural features and foundations of these language models. And again, I'm not an expert on this. Like, this is stuff that I have trouble wrapping my head around too. However, I almost do find that it's almost more difficult to like understand the words you're reading that explain these things than it is to actually understand these things themselves. It's just, I find that to be the case. But I did just want to kind of outline this, because if you're more interested in the actual like bare bones workings of these things, this coincided with the NanoGPT repository that we're going to play with right now, do a very good job of working together to make sense of these things. All right. If you're still with me, we are getting closer to actually being able to train and then subsequently play with our model. Now, following along with the quick start, we will see that we have finished preparing our data, and the next step is really to actually be able to train the model with our data. However, there are a couple of things we need to kind of tweak in order to make sure that everything goes smoothly and we can actually do that. The first is that we actually need to modify this train Shakespeare character Python script. This is sort of a kind of configuration override for the actual training script. So it sets some variables and things like that pertaining to the Shakespeare dataset, as opposed to the big GPT-2 training that can also be used with this repository. So essentially, we are actually going to, from the terminal, go into the config folder. And then using Nano, we are going to first list the contents of it. We're going to find the train Shakespeare character.python script. So just copy its name here and then type nano and then paste it so we can go in and make a simple edit to it. And what we're going to do is scroll down to the line that says dataset. And we will see here that the dataset for this is pointed to the Shakespeare character folder. Now, as we saw earlier, which I will just show on our local machine to give a little more like understanding of this, in the NanoGPT repository and in the data folder, there was Shakespeare and then Shakespeare character. So because we did this in the Shakespeare folder where we prepared our data, that is the location of the training and validation data sets we will use to actually train the model. However, this script is looking for that data in the Shakespeare character folder, but because we did not run the preparation script from in here, we ran it from in here. We just need to change this to reflect that. So fortunately, all we need to do is basically just make it say Shakespeare instead of Shakespeare-car or character. So we can then save this. And real quick, just some of the other things in here are kind of pertaining to the actual training of the model. So for example, the evaluation interval. So every 250 steps, if you will, and again, not scientifically speaking, it will actually test the model on the validation data set. Following that, the log interval. So every 10 training steps, it will actually show an output of like the training loss, the time, and then some other metrics and things of that sort. And then down here, we can see that there is a maximum number of iterations. So basically how many training steps it will take. And there is a LR iteration, which is the learning rate decay iteration. So kind of to quickly explain that, when the model is being trained, it's say its knowledge is being slightly adjusted to make it more likely to pick the correct word that follows the input that it's reading. Over time, the learning rate gets adjusted so it doesn't actually stay consistent throughout the entire, say, 5,000 iteration training run. It actually, and what we'll see here, it starts off at kind of a more aggressive adjustment, and then it slows so that towards the end of the training run, the adjustment or like the learning rate gets slower changes so that it does not have as drastic of an effect on the model. I understand that could be a little confusing, but it's just kind of to keep things consistent, I suppose you could say. And again, when we start training the model, we are actually going to see that the loss value will start off very high, and then it will get slower in terms of how much the loss value changes as the model's training runs. So we have changed this, and I do believe I saved it, but I just want to make sure. Okay. And the next thing we need to do is actually go ahead and modify the train script, because if we were to now basically just go ahead and run the training code or training prompt from here, I apologize. First and foremost, we would need to make sure that we do it from the actual like NanoGPT directory and not any of the subdirectories. But if we were to go ahead and actually run the training script right now, we will get some errors. And this is partially due to running it on the Jetson, but partially not. So we need to actually modify the training script as well to make a few changes. So we are just going to do nano train.py. And once we're in here, we see the training script. And this is quite simple, so we can just edit this in Nano. We're going to scroll down to where we see from Torch distributed import, blah, blah, blah. Now, this import is essentially for multi-GPU training scenarios, which on the Jetson, of course, we don't have access to. So there is no need to have this, and it can cause some errors. The machine behind me, which has multiple GPUs, is something that could take advantage of this. And obviously training bigger language models and things like that requires many, many GPUs. So that's kind of more what this is for. Now in Python, if we want to kind of just have the script execution ignore a line, we just put a pound sign in front of it. So we are going to put a pound sign in front of that bottom from torch.distributed. And I don't know if we need to put it on the one above it. I do believe we do. So just to alleviate potential errors, we are also going to do that as well. And this is called just commenting out these lines. So when the script is actually being executed, as far as what it's concerned, this syntax doesn't even exist, even though we can still see it. So that's called commenting out. Now that we've done that, we just Control-O to save it, and then Control-X to get back out of it. So once we have made the changes to the Shakespeare character config override right here, and also the training script, if we were still to go and run this right now, it would look like it's working, but it would probably just freeze up pretty bad. So there are a few optimizations that we can actually make to allow this to run more quickly on the Jetson and things like that. In order to find those, we just kind of scroll down here more in the quick start, and the section where it just says I only have a MacBook or other cheap computer, we see that there is the same command there. However, in addition to that, there are a bunch of flags here. Now, without getting too technical, we can kind of think of these as just performance optimizations that will be applied to the actual training run for the model. Now, we're going to copy this and open up a text editor. And you can see I have done that here, but we're going to do it again just to like live explain. Now, there are a few things here that aren't as important, but there is one that just needs to be deleted, and that is the flag to run the training on the CPU. Because we are using the Jetson, we don't want that flag, or it would just use the Jetson CPU instead of the GPU. And we can actually utilize the GPU, so we want to do so. And that would be more for, as it says here, like an old cheap computer that might not have a powerful graphics card, so you can just run this on the CPU if you want to just play with it. Following that, we have the compile false flag, eval iterations go down, the layers are smaller, and the max iterations are lower. So basically, this just trains it in a kind of like, imagine you're like doing like a big gym regimen, but someone comes in who's never been to the gym before. You basically give them like a simpler workout routine. That's essentially what we're doing here, but they're still training, but just maybe not as hardcore. So essentially, now we can actually get to the fun part and go ahead and actually run the darn training script, which is going to be exciting. Well, at least for me, hopefully for you too. So we just copy paste this into the terminal. And again, make sure that we are just in the NanoGPT directory. We don't want to be in any of the subfolders or this will not work. So typing pwd will just print your current working directory. And we can see that we are within the NanoGPT directory. Therefore, we are good to go ahead and run our training command. Now, while we do this, or prior to doing this, I am actually going to open the Jetson Power GUI because we'll actually be able to see the utilization of the graphics card when training this model. This will take a little bit of time, however, it is going to go relatively quick and we'll be able to see it and talk about it. So as we press enter here, we will see a few things listed, just like some of the overrides. We can, sorry, I'm pointing at the screen, you can't see that. And we can see that at the beginning, the loss does go down pretty fast. So that kind of touches back to what we talked about before with like the learning rate decay. I forget what it was called. But so, and here, so as we see on 259, iteration 249, it actually pauses for a second, and that's because every 250 iterations, it was actually going to test it on the validation data set. So we can see that when that happens, we actually get a new thing printed here, which is the validation loss, which we can just think of as like a metric of how the model's actually performing in general, because that's its performance on the unseen data. And as we scroll down here, we will see if I bring it down to real time. So this is going to go for 2,000 of these iterations total, as we saw in the override, and we can just close out of that system throttle. We can also see the GPU here is at 99% utilization. So basically, this is fully utilizing the Jetson's GPU to actually train a tiny little AI model, which is awesome. And we can see, so our loss is continuing to go down, and the time is just basically how long it takes for each of the iterations to run. And following that, we have this MFU, which I'm a bit rusty on, but I do believe it just kind of relates to how much of the GPUs being like used for the training run or something with flops. I don't know. That's probably a good one to Google to get a way better explanation than what I just saw. But we can see it is also saving checkpoints. So basically, when you are training models, especially imagine training like a huge gigantic model that has a lot of time, money, and resource invested into it, you want to save those checkpoints because you can think of that as akin to like making backups of your files. So you don't want to lose all your data or have a training run mess up and have no backups. So we can see that as we close in on iteration 2000, which will be the conclusion of this training run, our loss value has gone from, I think, somewhere a little over 10 when we started to a final loss value of 4.0556, which is the training loss. The validation loss has gone down to 4.7 something. And in terms of like worrying about like, okay, what does that number even mean? Not really in the scope here. Just know that like if the value goes down, that's good. It means the model is performing better on the unseen data. Now, training loss, and from what I understand, especially with small data sets like this, it is possible for the training loss, which is its performance in that iteration, to actually go down continuously, but the validation loss can actually plateau and then start to go up. That is referred to as overfitting, which is essentially where it's got such a small data set, it learns to perfectly predict what comes next. So it does a fantastic job on the training data, but on unseen data, it starts to do worse because it's basically memorizing its training data. So again, non-scientific, rusty explanations, but essentially now we have a trained Shakespeare tiny little LLM AI model, and we can go ahead and try the thing. I was going to swear because I got excited. I'm sorry about that. So in order to actually see where our model is before we go ahead and try it, we are going to go into the NanoGPT folder structure, and we can see that we now have this out-Shakespeare-character folder, which was not there prior to the training run. And if we click in here, we can see that we have this ckpt.pt, which for our purposes here is our actual model. So if we want to go ahead and actually test our model or sample from it, we are just going to clear the terminal here because we don't need to see that now. And we are just going to run this command. And once we do this, it is actually going to be running our AI model and generating little snippets of Shakespeare text that it was just trained on. So we can kind of just ignore this, and then we will start to see a bunch of Shakespeare stuff go on the screen, which is this is awesome. So like this didn't even exist a few hours ago because we actually did this all. Of course, it was the NanoGPT repository that we walked through, but we prepared the data. We set everything up so that we would be able to train this model on our Jetson. We trained the model on the data that we prepared, and it is now in a model that we are actually interacting with, and it is producing text based off of how we trained it, which we can see here. So it just outputted a ton of Shakespeare-esque text, if you will. And the thing I really like about this repository is that you can actually go ahead and make your own data source. So I have actually done this I scraped the RuneScape wiki just for a bunch of RuneScape terminology, and then I used that. I prepared the data on that, and then I trained the model with that data set instead. And basically when I would sample the model, it would just start outputting RuneScape text, and it was awesome. So not only does this give you a good foundational kind of understanding of how some of the big boy LLMs work, but it also kind of lets you play with it and modify it in a way that is approachable and palatable, in my opinion. Now, we're pretty much concluded. There is really only one thing I want to show, and that is we can actually modify the behavior of the output of the model here when we're sampling it. So to do that, we are just going to take a look at the sample script, which we can basically just do nano sample.py. Sorry, it seems like I'm losing my voice. I don't think I'm yelling, but I might be. So from here, we can see the number of samples that we're generating, which right now is 10. Let's just drop that to 1. The number of new tokens is 500 right now, and let's just drop that down to 150. Essentially what this is doing is, as opposed to the large amount of outputted text we saw earlier, this will just output like a much smaller amount of text, so we can kind of get a better grasp of seeing the model work in real time, if you will. Temperature is something that you may be familiar with or have heard of. In local LLMs, some people like to play with it because it can make the model more fun. So a higher temperature kind of evens out the probability distribution of the most likely token. Again, unscientific, but to kind of make sense of that, essentially if you have a bunch of tokens or next words, if you will, that are very likely to follow the sentence, raising the temperature kind of evens the field for maybe a token that otherwise would not have likely been next to equally be chosen. So it makes the model's output more flamboyant, if you will, or varied. Top K, which we see following this, which I'm not too versed on, but essentially it will keep like the 200 most likely tokens, and then the rest of them will be like equal to 0, so completely unlikely to be chosen. So I find that it can get a little confusing when like mixing up temperature with Top K, but there is like a difference in them. So, and honestly, as it says here in the comments, okay, so 1 is no change, less than 1 is less random, more than 1 is more random, and then Top K 200, retain only the Top K most likely tokens, others have 0. So retain only the top 200, the others have 0. Again, and basically something I find is if you want to like, oh, sorry, hold on 1 second, I got confused. Okay, so I'm saving that, and then X. To better understand some of that, just like even asking GPT about like the first from lines 12 to 23 here will give you a great kind of overview of what these things are really specifically doing in this scope. So we are going to once again sample our model, except this time it will be a much shorter output that we see because we changed it to 1 sample from 10 and 150 tokens from 500. So we can see that we have some Shakespeare-esque response here. Really, that's going to wrap it up. This is something that I think provides a ton of value because obviously it's more fun to just run a local LLM and OLLM and play with it. But the educational value that you can actually get from something like NanoGPT and a $250 device like the Jetson, I think far outweighs the actual purchase price of the Jetson, assuming you could get it at MSRP. I see folks maybe still having trouble finding them, which hopefully will get remedied soon. But this is just something I like a lot, and I think it's really cool because it gives you a palatable, like, it's like looking up at a big skyscraper and being like, wow, imagine building that. But this is kind of like being there while they build the first floor. So no matter how many other floors they put on the skyscraper, you kind of understand how it's all put together. That's what I love about this. And I think it is really cool and just something that I'm like passionate to make a video on and like an introductory thing. Like I said, nothing what I said in here was supposed to be taken fully as fact. I'm not an expert when it comes to this stuff, but I wanted to just kind of do a full deep dive walkthrough of actually being able to train your own AI model on your own data set on the Jetson Aura Nano. I think this is probably a cool way to spend a few hours on a Sunday or something like that, just playing around with it and learning. And I'm really excited about it. So I don't want to become a Jetson only channel, like I said, but I can't deny the videos do seem to do much better than my other videos. So I'll probably just do Jetson videos like every other video or something like that. There are seemingly a lot of fun possibilities with this and a lot of interest. So that is going to wrap up what was likely a rather verbose and in-depth video. If you have any questions about this repository or code, probably just Google it. But if you have any questions about anything else, feel free to leave the comments and ask. All right. Thanks for watching.